Okay, so let's look at these two different sequences. First, when you are dealing with a sequence, you want to identify the pattern. And so this first sequence, we are multiplying by 1/2 each time. Okay, and so if we want to write a recursive rule, all you need is the first term. You can call it a sub 1 or a sub 0. Doesn't matter. A sub 1 is 6. Our first term is 6. And then you would just say you get to any term by multiplying 1/2 times the previous term. That's what this symbol means, previous term. Okay, and so anytime you see the word recursive, it just means it's referring to a previous term. And so if you want an explicit rule does not depend on the previous term. It just depends on which term you want. And so we don't define the first term, but it is a part of the formula. And so for a geometric sequence, whenever you're multiplying it's geometric, you write an explicit rule using the first term times the common ratio to the n minus 1. So in this case, our first term is 6, our common ratio is 1/2, and we put the n minus 1. So this is the recursive rule in terms of the previous term, just multiplying by 1/2. This is the explicit rule. Take the first term and multiply it by 1/2, and then put n minus 1 in the exponent. And so we can do something similar for arithmetic. And so this next example, we are just subtracting 3 each time, which is the same as adding -3. And so the recursive rule first term is 6, and then you get to any term by taking the previous term and subtracting 3. Okay, and so that's the recursive rule, referring to the previous term minus 3. And so if I want the explicit rule, for arithmetic sequences, you get to any term taking the first term and adding the common difference n minus 1 times. And so for this example, we have our first term is 6, our common difference is -3, so we're going to have -3 and minus 1. And so that would be the explicit rule. It doesn't depend on the previous term. The recursive rule depends on the previous term.